Hi everyone, welcome back to the channel Talking Books. In this video, we are going to talk about empirical formula and molecular formula. Also, we are going to solve the NCERT problems based on these. Okay, we all have heard about molecular formula. What exactly molecular formula is, we know that it is showing the exact number of different types of atoms present in a molecule of a compound. Okay, if I'm talking about a compound, benzene, I can say its molecular formula is C6H6. Okay, it means this is having 6 carbon atoms and 6 hydrogen atoms. Okay, now what exactly the empirical formula represents? Then we can say an empirical formula represents the simplest whole number ratio of various atoms present in a compound. This is the definition. Have you understood anything from this definition? Let us try to understand. Since we need to find out the simplest whole number ratio of atoms present in a compound, you can see we have 6 carbon atoms and 6 hydrogen atoms. So, what will be the number that we can use to divide here so that we can get the simplest number ratio? So, let us take 6 number. If I divide 6 by 6, I am going to get 1. So, I will be having one carbon atom and one hydrogen atom in the empirical formula. So I can say the empirical formula of benzene will be CH. I think you must have got some idea from this example. If I'm taking another example of ethane, ethane is having the molecular formula as C2H6. If I want empirical formula of ethane, then what I will do, I will find out a number that can divide this 2 as well as this 6. So I will divide this by 2. If I'm going to divide 2 by 2, I'm going to get 1. If I'm going to divide 6 by 2, I'm going to get 3. So what will be the empirical formula of ethane here? It will be CH3. Okay, this is the simplest whole number ratio of various atoms present in a compound. Okay, now here in this video we are going to learn how to find the empirical formula using the mass percent of various elements present in a compound. Such kind of problems are given in our NCERT textbook. Here is the NCERT problem. Let's try to solve this. How to find out the empirical formula using the mass percentage. Let's read this. The question says, determine the empirical formula of an oxide of iron which has 69.9% iron and 30.1% dioxygen by mass. Okay, what is given here? We are given with the mass percent values of iron and oxygen in this manner. Okay, in order to determine the empirical formula of this oxide of iron, we need to follow some steps. The first step is that we need to convert the mass percent to grams. Since we are using the term mass percent here, so it is convenient to use 100 grams of the compound. Okay, if we are having 100 grams of compound, then what will be the mass of Fe here? The mass of Fe will be 69.9 grams. And what will be the mass of oxygen? It will be 30.1 gram. Okay, now coming to the second step, we can say we have to convert the mass of each element to moles. Do you know how to calculate the moles? We can use a formula that moles are equal to mass divided by atomic mass, or in place of atomic mass we can use the molar mass as well. Since we are having elements, therefore we are using the term atomic mass. Here you can see the atomic mass of Fe is 55.84, that is nearly equal to 56 grams per mole, and atomic mass of oxygen is 16 grams per mole. Okay, so in order to find out the moles that are represented by small n, we can write here moles of Fe will be equal to 69.9 grams divided by 56 grams per mole. Here, what we can do, we can eliminate the gram unit. On solving this, we are getting the value of moles of Fe equals to 1.25 mole. In similar way, we can calculate the moles of oxygen. The mass of oxygen given here is 30.1 grams and its atomic mass is 16 grams per mole. Here also we can eliminate this gram unit. On solving this, we are getting the value of moles of oxygen equals to 1.88 mole. Okay, this is about the second step. Now coming to the third step. In third step, we need to find out the mole ratio. How we can find it? Let's see. Here, we need to look for the moles which is smallest. We can see it is the Fe which is having 1.25 moles, which is smaller than moles of oxygen. So we need to write the moles of Fe as 1.25 and moles of oxygen as 1.88. Now divide moles of Fe by 1.25 and divide moles of oxygen by 1.25. On solving this, we are getting the value as 1 ratio 1.5. We are getting some decimal value. We need an integer value. So what we will do, we will multiply this by a number so that we can get an integer value. So let us multiply it by 2. On doing so, what ratio we are going to get here as 2 ratio 3. Okay. So here we can write that the simplest whole number ratio will be 2 is to 3. That is, we will be having 2 Fe atoms and 3 oxygen atom. Hence, the empirical formula will be Fe2O3. I hope you understood this solution. Initially, this problem seems complicated, but actually it is not. It is very simple. What you have to do, you need to look for the mass percent values. You need to convert it into the mass. Then you need to know about the atomic mass of the given elements. Then you should find the moles. After that, the mole ratio, and you will be getting the simplest whole number ratio. And here will be the answer. Okay, now coming to the next problem. It is given that determine the molecular formula of an oxide of iron in which the mass percent of iron and oxygen are 69.9 and 30.1 respectively. It is the same problem, and here we need to find out the molecular formula. Okay, now let's see how we can find out the molecular formula. There is a one expression that molecular formula is equal to N into empirical formula. What does this N represent here? The N is an integer value that is equal to molecular mass divided by empirical formula mass. Okay. So first of all, let us find out the empirical formula mass. We have empirical formula Fe2O3. Okay. So how we can find out this? We have two Fe atoms in our formula, and each Fe atom is having the mass 56 grams per mole. This is the atomic mass of iron. Plus we are having 3 oxygen atom, and each oxygen atom is having the mass 16 grams per mole. Okay, let's simplify it. 56 into 2 is 112 plus 3 into 16 is 48. On solving this, we are getting the empirical formula mass equals to 160 grams per mole. In case of oxide of iron, the empirical formula mass and the molecular mass will be equal. Okay, so if I put 160 grams per mole here and 160 grams per mole here, then what value I will be getting? The gram per mole will be cancelled, and 1 is the answer we are obtaining. So what we have to do, we just simply need to put 1 here and empirical formula here, that is Fe2O3. On multiplying this, what we are getting? We are getting the molecular formula as Fe2O3. It is the same only. Most of the time, we are always given with the molecular mass in the question itself so that we can easily find out the value of N, and thus we can find out the molecular formula. So this is the answer. I hope you liked this video. Don't forget to like, share and subscribe this channel. Thank you very much.